Hey there guys, this is Adamant Life and we are here for another design stream. So actually let me pop back over here. So the plan was going into this week is that I would not do the quick contest for this week. And when I saw it was motor visualizers, I said, oh, that's great. And motor visualizers, aside from something like this, which, you know, had I not seen this, I probably would have considered doing. But motor visualizers are pretty boring, frankly. People just throw random things on it and make it spin. That being said, I saw this guy in here. This guy's awesome. Give this guy a look right here, this spider thing. It's a little unsafe if you don't have enough string. You kind of need to set it up properly and know exactly how many rotations you're going to need. Otherwise, I mean, at least from what I'm seeing on it, it's one of those things. Maybe there's something I'm missing. But the idea here is that this spool right here pulls this spider up, which is really awesome. But again, it seems to have a slight flaw in my opinion in that you've got to get the string length just right in order for the spider to go from the floor to the ceiling in X number of extrusion steps. But it is an awesome idea, I'll admit that one. However, point being, I was not planning on doing this guy because I wanted to make sure I had this guy done. And we only have 2 weeks left on this guy. And I wanted to make sure that I had a good entry for this one. I have a good idea. I got to do a lot of prep work on it, but we are going. I'm really looking forward to entering it. So, when I saw that the motor visualizers was the contest for this week, I was like, cool, no problem. We're gonna skip it. We're not doing this one. And then I went to bed and I said, yep, definitely not doing it. And then I woke up and I have no idea what kind of dream I had, but the second I woke up I went, wait a second, wouldn't it be cool if? And I wish I knew what dream I had that prompted all this, because I would never dream that dream again. Because I really didn't want to enter the contest, but it really would be cool if. So, what is the idea? The idea is that all of this stuff is just random plastic that spins around. Why don't we add lights to it? And I thought of a couple different ways of doing it. Right now, this is where I'm at. Let me swap back to the camera. This right here is a bunch of electronics. Runs off of 5 volts. This right here, as soon as I get it detached from my pen, these are magnets. You will see that this goes on and off depending on whether or not it's detecting magnets. It's a little, my pins on the back here powering it are a little off right now, but point being, you can see that working there. So that's a Hall effect sensor, if you don't know what that is. Detects magnetic fields. I only have this magnetic switch sensor. I looked at Amazon. Amazon can get me a analog version, you know, within the next 24 hours. So, being as I technically could have this all together within 24 hours, I figured I'd go for it. So, the idea here, the design idea here, is that this is not specifically a design. It is something that you go and you take any one of these guys, toss any one of these guys onto the front of it, and all it does is add lights to it. That's the idea. It's an add-on, not a product itself. And what I'm thinking is one of those things, we've got a round rotating thing, so basically we'll have a little cover here, have Hall effect sensors positioned 4 points around here. Right here, these are the magnets I have. I don't have any other magnets this size. I looked at attempting to get bipole magnets, but on Amazon, which again is probably the fastest I'm going to get something, most of them, 90% of them, are neodymium double-sided ones. So one of these sides, one of these flat sides is north and the other one is south. That's not what I really needed. I needed north and south like this to make this easier to work, because the analog voltage will go up and then down as it passes from north to south. But it should work out more or less in this orientation. I should be able to get it to work. So you can see those just snap together. So long as I keep opposite faces, so long as I press in whatever opposite faces, you know, a little bit spaced apart, we should get something approaching what I'm looking for. So we've got Hall effect sensors. This is the fan shroud right here. or not the fan shroud, the extruder right here. Little cover, Hall effect sensors, and then there's a little shaft, let's say, with a magnet attaching to the extruder, and then basically a fan type thing. I mean, it really only needs one fin on it, so it's not really a fan, but that holds the magnets, and then it spins around. And as it passes the Hall effect sensors, I actually don't know what the schematic symbol is for a Hall effect sensor. I'm just going to draw a light resistor just for the heck of it. So these doink, 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 doink. These are all plus on this side, and then I'll use a common cathode LED. RGB, and then that's minus. So that's how we'll run it. And as the Hall effect sensor passes through each of these, it will trigger, RGB and rotate through the colors. And as it passes through, because it's an analog sensor, the red will get brighter, and then the blue will get brighter, green will get brighter, etc. So that's the general idea. And then the front of this will have, anything really. It could just be open, it could be a magnet, it could be a bolt, for all I care. It could have something there, and then you just stick your actual motor visualizer on the front. So that's what we're going to design. That's the idea I came up with and how I'm planning on running it. Looks like I might be dropping frames for the first time in my life. No, maybe not. Interesting. I see the preview window on YouTube spinning. Let me pause and replay here. I'm just going to refresh. If you're getting some hiccups on YouTube, I apologize for that one. On my end, in my streaming software, it doesn't say I've dropped anything. So don't know why YouTube's doing that. Anyway, back to talking about the project. So one of these things, looking at where we're going to get 5 volts on, because that's really important. At first I was like, well, the fan's right there, it's right below it, so it's the first thing I thought about, but fan's not always on, so the fan's not really going to work. The thermistor, I can't remember if that's 5 volts or 12 volts, 24 volts, etc. It might be 12 volts, I'd have to check, but regardless, that's also not always on, so not really going to work. So then I realized, the filament sensor is right there. That is always on, the filament sensor. I'm pretty sure it's constant 5 volts. So we can hop off of that. As for, then we got to consider power draw on it. The fact of the matter is that we're only running one LED at a time at this point, unless we change the design. So since we're only running one LED at a time, we're pulling about 20 milliamps off that. And then the Hall effect sensor that I was looking at on Amazon said that it only pulled 6 milliamps at maximum draw. So we're only at 26 milliamps, so I can't imagine us frying the board over 26 milliamps. Maybe I'm wrong. Hopefully I'm not wrong. But that's the plan. The plan is to splice off of the filament sensor. It's right there at the top of the extruder anyway, so just splice in a connector to run the 5 volts. And that would be everything. What was this one? Oh, this was just me looking at the fans, is all this was. Yeah, alright, so over to Fusion. Alright, and in Fusion, I just got us prepped by getting my neodymium magnet in here. Since I've used these guys before in other projects, I was able to just drag it over. First thing we gotta do, I don't think I actually... Give me half a second. Let me dig through some files really quick. I don't think I have a... Oh, I do have a NEMA 17 stepper in here. Is that the same dimensions as the extruder stepper? Let me just check really quick. Inspect. 42. not in inches. Okay. Yes, I do in fact have a NEMA stepper. Cool. Alright. That is the correct NEMA stepper. I have no idea how that file opened up there. Fortunately, you're not seeing it because you're at my desktop. Alright, back to Fusion Desktop. Insert into. Yeah, proceed. Close that out. Alright, there we go. So now we have our extruder. Good start. And now, again, I'm thinking. So I was thinking about putting a cage on there. I don't know that it's gonna, looking over at my Prusa, I'm not sure it's really gonna fit without modifying the rest of the hot end. You know, and doing an attachment point. Technically speaking, we might be able to fit it in between the blower and the but rather than do that, I think we're just going to anticipate that the amount of weight we're putting on this thing is minimal enough that we don't need to. That's what I think we're going to hope, is that just the weight of all the components, one LED, one RGB LED, a couple magnets, and etc., is not going to be enough to make it fall off from the 8mm magnet. So let's get started on that. I'm gonna do a new component because I don't have an 8mm magnet component made up from any other previous designs. And I will go ahead and, where do we want to put this? I guess do it on the front. Just turn these guys off to get out of my way. 8mm magnet. Oh, duh, 8mm. What am I doing? Okay. And then on the other screen, give me half a second while I Google 8mm magnet. Let's see what a common size is. Just again, hop over to Amazon because I don't own one, so I'll have to buy one. 8mm magnet. Let's see. So they come in. I see 2mm. I see 3mm. I see a lot of 2 and 3mm. Looking at, it's interesting. Looking at the Prusa, I feel like I need a, because the shaft is inset and hard to get to, I feel like I need to use something. And I guess this is just a matter of 3D print a part and stick it in there. Wow, that's tight. That's only 9mm on the inside there. Let us look at some other designs really quick to research because I've never made one of these before. So I'm going to have to check how other people how they go about getting that magnet on there, because is this a 3D design? Huh. Really? I can't see the back end there, dude. Let us see. And just an inset for the magnet. And it just hovers? Like, how's it making contact with the... Okay, and that doesn't even have... That's not even the right model. Unless I'm missing something. Huh, am I missing something? Whoops. Go back. Let's see. Does anybody have a good... you look like you might be able to show me. Huh. Fascinating. So, again... I mean, looking at my extruder. Taking measurements. Alright, I've got... Okay, you know what? it's only 2.7, so if I get a 3mm, then that will at least be out from the machine. Okay, we can do that. Again, I'd feel more comfortable if I had a little bit more space between the extruder and the printed parts, but where's Fusion at? Where'd that go? There it is. I guess we'll just plan on a 3mm magnet at this point. And I'll just use chrome again for the magnet. And that gets that set up. And I will go ahead and modify this extruder. Do you already have a plane there? Let's see, plane. Nope, only on the front plate. So let's go ahead and toss this hole in here for reference. Okay. Bodies. Turn the other stuff off. Turn the shaft off. Actually, I can use the shaft here because the shaft runs straight through. Cool. Good deal. Turn the body off. Turn the shaft off. Hit that. Make this concentric to that. And this was 9mm is what I measured. So we are just going to extrude that. Minus 2.77 is what I had. And the shaft doesn't actually run all the way through, it looks like, when I designed this. So that is alright. We'll be alright. So I'm going to take this magnet and align it on the inside there. I guess I'll turn this off to make it easier. Center that. Magnet off. Center that. Magnet on. Cool. Alright. That gets us there. We'll capture position, and then I am going to as-bit joint that and that. And yeah, we'll leave that rigid. Now, if I spin this, I should see, yeah, it looks like, it's hard to see, but looking at the little reflections here on the edge here, I'm pretty sure that's, I think that's spinning. Yeah, we'll find out when we put something on it. So, this, we're going to need a section. Okay, so we do need a section that is rigid in order to keep the Hall effect sensors from spinning. We will also need, well, alright, right. So, I don't necessarily, I have done plastic PCB plates, PCB boards before, so I'm pretty comfortable with it. Hey, Wrath, thanks for showing up. Thanks for tuning in. I have done plastic PCB boards before, and they aren't terribly bad. You just got to drill everything out because obviously the 1.2mm are a little tight in there, leads. So I'm comfortable with that, and I think that's how I'll design this for right now. So let us go ahead and toss that in there then. PCB. And like I said, since we're doing this, we can go ahead and build that straight into the thing that keeps it from rotating. And we're also going to want to attach, well, no, I can just write in there. And I'm not really concerned about a bearing. Am I concerned about putting a bearing in here to make it easier to roll? I don't really think so. I think I'll just let it be plastic on plastic. So, actually, before we do PCB, I take it back. Let me do indicator. Motor indicator, yeah. And then I'm gonna do housing inside of here. Housing or shell, one of the two. Shell, I'll call it shell. Name doesn't necessarily matter. And then we will go ahead and take a plane off of the back of the magnet and start drawing the general outline. And one of those things, it can be modified in the future because this much plastic is really not necessary. And I'll just take these sides for right now as my boundaries and work off of that. And I'm gonna want, it's one of those things, you can do this one of two ways. You can either draw the walls separately and then join them, or leave your space for the walls ahead of time. So back to, I'm gonna go I'm gonna opt to do that here. So wall thickness 3 millimeters. Wall thickness and wall thickness. And again, this plate right here, this shell, is just to hold everything in place. And we don't need this down here, and in fact I prefer for it to be a little bit up, just so that it doesn't interfere with the wire harness at all. So we'll just leave that 5 millimeters from the bottom, and we will go ahead and use the 9 millimeter hole on the back as our through hole, rather than actually no, I take that back. We'll use the 8 millimeter magnet. That way we can keep things tight to the magnet. And let's extrude that out. So there's that, and then I'm just going to come around the back side here. Actually, let us do this. I'm going to open this back up really quick. Yeah, we can just modify this sketch, and I'll do it this way. Bodies. Okay, other bodies. The motor and the magnet. Turn those guys off. Collapse everything, and I am going to go ahead and turn these into construction lines. Attempt to turn these into construction lines. Oh, that's right. I took a face, so therefore there's two edges here that it's picking up. That's why it looks like they're not turning into construction lines. And then we're just going to toss this guy in here. Doink. Doink. And this is effectively my offset. The other way of doing that was to draw an offset through here, and then 3 millimeter offset, draw the square and draw a 3 millimeter offset, and then throw a cross line. Again, there's 1.5 million ways to skin a cat. This is the way we're doing it today. Alright, so we're gonna bring this up, and just for reference, NEMA step motor, distance to object. Whoops, not that one, not that object. Turn the body off, get that plane, turn the sketch off so that I can get object and choose the back here, and then we will go, let's say 10 millimeters for now. Or actually, wrong one. That to object, and then 10 millimeters. Minus 10 millimeters. There we go. And that is the shell, and it's one of those things. I'll hop in here just to give ourselves a little bit of breathing room, because it is 3D printing, and 3D printing needs a little bit of extra space depending on print settings, tuning rather, your printer tuning. So that sits on front, and that just keeps everything that we're going to be putting on here in line. Now, we have different options of how to design this. If I'm looking at how this is printing, this is probably going to want to be printed like this at the time being. It could also be printed face down like this. So let me actually, if you imagine this is the printer bed right here, we're looking face down on the printer bed. It could be printed this way, or like I said, the printer bed is now this side. It could be printed from here up. Both of those work right now. This way, sorry, look at this. With the printer bed this direction, this preserves this circle right here. This is printed a lot cleaner. However, we can't put anything on the front, and I think I do want to print this as one piece, the PCB board that I was just talking about. So we're going to go ahead and do that. And the other thing to mention is, again, back to I said it doesn't need so much plastic. I may come back in here and hollow this out just to save on plastic. That's it's a minor save on plastic. It's like 1 or 2 cents, so maybe not. It might save, you know, maybe 10 minutes of printing, let's say, only because it has to put additional walls in for every space that you put in. So may not be worth it. We'll look at it. Coffee. So, excuse me, sorry. Looking at this, we now want to put the PCB board in for the Hall effect sensors. And now I'm double thinking how I want to do this, because actually, let us flip back around top. We're like this right now, so I could actually throw some mounting holes in here and then put it over the front here if I want to print it in 2 pieces. So it's still open. The printing options are still open, so we're just going to move forward with the design. Anyway, back to the PCB. Now, one thing I don't know, because I don't have the Hall effect sensors on me right now that I'm going to be using, the analog Hall effect sensors, is whether or not, new component, what exactly their sensitivity is. And honestly, even if they do overlap a little bit, that's alright, because I'll give ourselves 3mm, I guess, because that just means that we'll get a mix as we're going between colors of red and green, red and blue, blue and red, green, etc, etc, etc. So as we spin around, we'll get a mix of that, and therefore it's not necessarily bad if they do overlap. And thinking about this further, if I do print it like this, yeah, I can print it like this, so it doesn't necessarily matter yet. I was going to say we may have just come to the point where we got to make a decision, but that is not the case. So looking at the Hall effect sensor that I downloaded, oh, they're on my other account on my computer, so I did not download on this account. I'm going to assume that the Hall effect sensor is the same size as the one I got here, just for dimensioning sake. Alright, so this is 4mm wide body, and I'll just say the leads are spaced 1.2, I forget, lead spacing 1.25, no, 2.5, 2.5. 2.25? What is lead spacing? Gosh darn it, I don't do PCBs enough. PCB lead spacing. Standard spacing. Alright, breadboard. Because a PCB is printed and therefore it can be any spacing you want. So let's go with breadboard for the heck of it. Let's see, internet, what do you say? What is my pitch, breadboard? What is my pitch? Hmm. 2.54. That is absolutely correct. Now that I'm saying out loud, that definitely sounds correct. So I'm just going to use that. Point being, as I'm just going to use that for the spacing here. Technically speaking, these Hall effect sensors could be a lot closer together. From the looks of it, again, just going off this one, the actual spacing on it looks to be about 1.2. But it's one of those things. Breadboards are already congested enough, so I'm going to go ahead and just use that as my spacing. So let us grab a center line here, turn some stuff off, turn the magnet off, turn the shell off, and I'm going to grab a center line straight off over there, go perpendicular to that, and the midpoint, and 2.5, or actually, I take it back. So do I take it back? It's technically 2.54 times 2, right? Is what it is, because this center point right here is what I was thinking. So if we look here, that's 2.54. So yeah, that's how we'll do it. And now the next question is how big we want to make this rotation, and that's where the matter of what the sensor is, how close they can be together and the overlap of the magnetic fields, and therefore the effect of the Hall sensors at those distances. That will determine how much overlap we have in RGB. So that's something I don't know just yet, because again, I don't have the Hall effect sensors. So I'm going to just call this 20 for right now, and we will come back if we need to, because it is just an easy modification here. Blanking on what one of the things again. I don't do these all too often. Yeah, okay, I'll just call it 1 millimeter. The holes for this to go through is what I'm looking at right here. For the lead to go through, just gonna make 1 millimeter holes. Actually, let us do this the right way. Modify, change parameters just in case. Lead holes, PCB, via, nah, I don't know. Lead holes, I'm just gonna call them lead holes. There's a bunch of things I could call them. Lead holes, okay. And actually, I'm just gonna hit the enter equal button. No need to complicate things, have numbers all over the place. And let's do lead pitch 2.54. Okay, correct this guy. Lead pitch times 2. Okay, and now I want to go ahead and have an offset here, and we'll just make it 3 for right now. And this guy actually should still be that. And I think that's everything I wanted. So we are going to extrude all this out for right now. Actually, fix that. What did I just undo? Redo. This guy should be, there we go. So extrude this out, wall thickness. Yeah, wall thickness is fine. I take it back. I'm gonna do 2 millimeters instead of 3 millimeters for the PCB, because there's no need for it to be that much thicker. And then we go ahead and obviously swap these guys, or run these guys through, extrude these through. Distance all, and okay. And then we can go ahead and create pattern, circle a pattern that, whoops, not faces, features. I'll grab the axis while we're here and select the feature. And we want to go 4 times, no, 3 times. We have 3 LEDs, so 3 times. So we'll have an Hall effect sensor poking through each of these on this side. And it's one of those things with PCB components, we're going to want to bend these straight up. So you can imagine a Hall sense center. Actually, let's go ahead and draw it really quick. No reason not to, right? So, new component. Not Hall sensor. Oy. That was a little bad. Alright, we draw in front. And I said this was 4 millimeters. And the height is, looks like 3 millimeters maybe? Let's see what it is. 3.25, I'm getting. 3.25, okay. And then, it's one of these things, this guy, whoops, these magnets are making a mess of everything. These guys, I'm just going to chamfer that edge instead of lofting it. So the thickness is, I was thinking about lofting it up, but no real need to. Let's get this centered on its origin, just for propriety's sake. And, whoops, centered on the origin. There we go. 1.45 is its thickness. And then again, we'll just chamfer these sides. There we go. And if we want to, just for funsies, whoops, that is not what I want. Sketch. I wanted text there. And it was the, shoot, which one did I pick out? 49E? 49E, I believe, is what we've got. And center. Okay. We'll pop this on here. Just for looks. It's just for looks, so I'm not, you know, being super specific about how it is. 7.5. Cool. And I'm just going to sync those in. Or actually, I'll bring them out 0.1. 0.01. Just a little bit. Just to make it easier to come in here. I'm going to make plastic. Oh, there it is. Derp. Plastic matte over here, and then faces, white. Do we have a white text or something like that? Like white. It's just gonna be plastic. Okay, that did not work. There we go. Yoinks, yoinks, yoinks. There we go. Now we have an Hall effect sensor. So let's hop back over to the PCB, turn that on. And we're going to align that, modify, align, center. Actually, no, not center, actually. I take it back. Whoops. Stop. Random drag effects in Fusion. I want that guy. That's what I want. And we'll put that there and rotate. Okay. Yeah, it looks good to me. Good enough at any rate. Pattern. Again, this is actually just completely unnecessary, but it makes it look better. So there's that. And let's go ahead and plastic blue. Grab a blue. Actually, where's my plastics? I like this blue better. There we go. So there's our Hall effect sensors in place. We're also going to want, well, actually, we don't really need a separate. Let's do it anyway. I'm going to come back in here. Come back. One of these things come up to the PCB, my bad. What's going on here? What did I double click? Alright, we are now at the PCB. Good. The Hall effect sensor should have at least one resistor on it for current limiting the LED. So I'm going to go ahead and throw that in too. It's not the Hall effect sensor that I have here that I was showing you on my desktop. That guy. Actually, let me do this. That guy also requires a pull down or pull up. It requires a pull up resistor on the between the output and the input in order to work. In order to not float is what it does, and so that it's not floating, it needs a pull up resistor. I don't know with these ones yet. I haven't looked at it yet, but I don't know if they also require an additional resistor. But this resistor, at any rate, I don't need that little one. This resistor will be for current limiting on the LED. Whoops. Equals. And this will just be actually, what's comfortable? 8 millimeters for an LED, 9 millimeters, 10 millimeters. Yeah, I'm gonna do 10 millimeters. Not LED, I meant to say resistor. for the resistor spacing, we'll go with that 10 millimeters. I'm not going to sorry, I'm thinking about how I want to go about this, whether or not I want this here or if I want to just use an offset here. I think I'll just use an offset here. 1, 2. Okay, good enough. The I won't model the resistor in this time, just because, again, the Hall effect sensor makes a little bit more sense. The resistor, less so. Actually, let's back all the way up here and take these out here at this point. Distance all, okay. And then, whoops, you're supposed to be back one more. And then we can select that one as well. There we go. And now we're updated. So, Hall effect sensor, and then resistor right below it. And that should be good. The next thing that we can do is come back up here, turn the shell on, look at it. And this guy, oh, whoops. Whoopsies. All right, come back here. Where's my positioning? There it is. You are on the wrong side. Not turn the Hall effect sensor off, turn that body off. And turn that sketch off. Select that. Turn this body back on. There. Flip. There we go. And capture position. And now we can look at this. And back to this may be printing in 2 pieces, this may be printing in 1 pieces. I'll make that decision in a little bit. It probably should be printed in 2 pieces to make it easier to wire. Otherwise, what I could do is I could, again, cut this part out here in order to get to the wiring. So it could be printing in 1 piece, but if it's printing in 1 piece, again, we're going to be printing like this because we can't print face down like this because that's in the way now. So we will probably be printing this in 2 pieces. And if this is printed in 2 pieces, we're going to want to come back up here and add an attachment point to the top. So let's go ahead and do that. So let us take our plane here, and then we'll take, whoops, the projection on the outside, and we will project that. Okay. What happened there? Project that. Okay. And turn all the bodies off. Make those. Turn the shell off. And then we just want to add a connection point. So this will be 3 millimeters wall thickness. And these guys will be tangent, tangent, tangent. And yeah, we'll go ahead and just go for the center here. So we'll make sure that this intersects that. I'm not actually sure. Oh, I know why. Because if this is going to be tangent anyway, then that's automatically going to derp. Okay, and then we'll just turn that guy back, and we will take this guy and extrude it. Distance to object. There. Join. Why? Why can't we? Need no understand. Turn body on. Distance to object. Click. Alright, it worked this time. Good. And then for connecting to the shell, we will go ahead and probably just run this back over. So we have a couple options, right? We can make the front thicker and then put the countersink bolts in there, or we can make the top thicker and put the countersink. I'm not making a motor. We on the printer, on a 3D printer, we have various NEMA 17 motors around. One thing that's popular is because the extruder motor is right in front, this being the extruder motor, the thing that pushes the plastic. Because this extruder motor is right in front and it's just basically dead center of the motor, kind of, I mean dead center of the machine, kind of, it's, you know, right there where you can see it. A lot of people will go ahead and, let me swap over to this just so you can see. They'll make little doodads like this, where it just sits on the front there and it spins. They're called motor visualizers. So they're just nice little cosmetics to spice up the machine. And again, they just spin around as that extruder spins. You can technically put one on any motor and it would work, because all these Nemo motors, at least all the Nemo motors on 3D printers, tend to have the shaft available on the back. That's especially important if you want to put an encoder on the back. So people will do this just as for cosmetic purposes. My idea for this project, whoops. Actually, I can go ahead and hop back over to the desktop, is running an LED off of this. And this is just a green LED there, but we're going to have, as you can see in Fusion, let's hop back over to Fusion. We're going to have multiple of the Hall effect sensors going around here so that we can detect multiple LEDs, which all are technically encased inside of one RGB LED. So then we effectively can create RGB colors off of it. So that's the design idea. So back to this again. I think I'm just going to build this up, put captured nuts in here, and run this back. So let's hop in here. Project. We'll take the top here and that face. Huh, did I not get that face? Did I miss? There we go. And turn everything back off just so that we have an easier time seeing. Shell. Construction lines. Look at. And we'll just take this through here. Line everything up. Technically speaking, this isn't even necessary. I should just leave these as is and just extrude off that. Makes life simpler. PCB. Let's see. Shell. Now the question is, yeah, I think I will just run this distance to object like this, and then we'll put the mounting bolts vertically over here. I could do the mounting bolts like this, but we will opt not to keep things a little bit simpler. So let's do this to throw in some holes. Center that on that. Go there. These are just reference lines right here to get things centered. And we will go ahead. Yeah, I don't really need this line. I can just do it with this one. And we just got to make sure that is perpendicular to that edge. And we'll use M3 bolts like normal. And that's right, because we're using M3 bolts, I'm going to have to pick that up, but that's okay. Finish. Let's come back here and correct that. That should be 5. Or, yeah, I'm just going to make this 5, generic 5. And then we'll extrude this out, or re-extrude this out without the holes, rather. There we go. So the bolts come right through. And actually, that's right, because we didn't extrude that out in the original design. Yeah, let's change how we're doing this then. That is correct. We'll do this. We'll move these guys. Nah, it's easier to move these guys over here in that case. And also I should position these relative to that just for propriety's sake so that they're locked in. I'm just going to extrude this all the way through to make my life easier. Distance all. Rather than fiddling with the design, the sketches. And then up here, and actually No, that's fine. We can come back to the shell, and we'll use that plane. Nah, we'll make a new plane. Do we have a plane for the front? Nope, just for the back. Inside, back, just so I know what it is for future reference. And then this guy's going to be the front. Front, and that guy was inside, back. Inside, back. There we go. So, toss this in here. Get all this reference points that we need. And then we just draw in the nuts. Easy enough. So, turn the body off. Turn the shell off. Whoops, not the shell itself, because we're working on that, the body. And we will toss the nuts in. We'll have that be parallel since that's the furthest away from that. And then M3 nuts are 5.45. And we will have to make that bigger, obviously, in order for these to fit. Actually, no, we don't. We don't need to. I take it back, 5.45. Because we can just come in here and set an offset. 2 millimeters. And from here, actually, we'll just have this being collinear with this to keep everything nice and clean. And this can just be collinear with the base there. So let's go ahead and extrude this. Turn the body back up, not that body, this body back on. And I'm just going to make sure that this is from not the sketch. Turn the sketch on. From the body. Now we can turn the sketch on. And whoops. What did I do? There we go. That, and we'll just go back. Actually, we'll go back like this. Yeah, we'll just use wall thickness. And that should be minus. And then we'll do the, there it is, the captures for the hex nuts. Object, back. And hex, 3mm hex nuts are 2.5, if I recall correctly. And I should be selecting that. I missed. And we join. Okay. And then we come back in here, toss these two construction lines, or not construction lines, and extrude those all the way through for the bolts. Distance all symmetric. Okay. And that completes that assembly. Let's hop up to the motor indicator. So bolts go through here, bolt that to that. That allows us to have an easier time with wiring this together because we can just take it off and put it back on. Meanwhile, we're going to need a through shaft to connect the magnet that goes on the back here, that neodymium magnet, or I'm saying neodymium, but whatever magnet this ends up being, connect to the shaft, run all the way through to the front. So that's the next point of, next thing to get done. So new component, and through shaft, okay. And project, whoops, that is correct. We should, let's see, where is, do we have a sketch plane? No, we do not have a sketch plane yet. Let's turn this stuff off, throw a sketch plane on that, okay. We can turn that stuff back on now, turn that off, turn both of these off, and start from there. And we project the magnet. Okay, and it only really needs to be that 8mm. There's no real sense to make it any bigger, technically speaking. So we'll take that distance to here, and then we're going to need some space for the Hall effect sensors and a little bit of extra space just so that we don't collide anything. Hall effect sensors were, I believe, if I recall correctly, 1.45 plus, a little bit of extra space, so we'll call that 2. And then if we give ourselves another 2 millimeters of space just for play, that will be 4. So we can extrude that like that. And we are on the through shaft body, so let's go ahead and color this something. Plastic. We'll make it orange so it stands out. And then this guy is going to have the wiper on. Well, not the wiper. It's kind of the wiper, it's kind of not the wiper. But the thing that holds the neodymium magnets, which, again, are now sticking to my calipers again. And what I was going to say is that we already have those in here, so I'm going to go ahead and just drag those down here into the through shaft. And we will go ahead and, whoops, try not to click the origin. Which origin is on right now? Not that one. Alright, anyway. Just don't click the origin. Just be good. Don't suck. Alright, project. And again, this is just going to be a fin. Our neodymium magnets are 5x3, so I'm going to throw a... well, this is the other thing. So, hopping back over to the camera really quick, just to demonstrate. These magnets that are now stuck together. Alright, there we go. Try to get them stuck on ends like I had them earlier. There it is. So, I don't know how well, again, I don't have the Hall effect sensors, they're ordered, they're going to be coming. I don't know how well they're going to work if I stick them directly together like that. So we may need to space them out a little bit. So for right now, I'm going to do the, I just realized, these, this is the 10 millimeter distance right here. Technically speaking, I don't think it should matter. It's one of those things I'll have to experiment a little bit, whether it's like that or that, whether it's on that side or that side, putting them together. This is north face, this is south face nominally. I'm not actually sure. One of them's north, one of them's south. Point being is that we may need, it may work better with a little bit of space between the two, the LED effect. So I may need to incorporate that. And again, I don't know whether or not it's really necessary to do them long ways or just like that. It may be, I think I'll design it like this just to save space. So we'll have the 5 millimeters, and I'll even go ahead and put a 5 millimeter gap just because we're already saving space, and then the other 5 millimeters. That's where we'll start. I'll experiment because I'll leave the 5 millimeter gap as an inset, so I can just literally slide them back together. So they'll start out like this, and then I'll be able to just slide them over, assuming I don't glue them in, for testing purposes. So that's what we'll do. So let me come up here and check my parameters, and I do have magnet length, height, thickness, etc. So let us go ahead and make this magnet height, nope, length. Okay, so that's our 10 millimeter side. And then this we're going to make magnet height times 3. That way I have an extra space in the middle to slide it over to. And again, this, we only need one fin, so it doesn't necessarily matter that it's taking up so much space because this will just spin around. It will be the only thing spinning around. So we're all right there. Let me just turn some stuff off so that I can make sure I'm not accidentally clicking the bodies, which sometimes happens in Fusion. Sometimes you think you're clicking onto a sketch line and you end up clicking onto a body instead, which is a bit obnoxious. So we got that in there, and I will just make this vertically constrained. And let's see, I probably should go ahead and have this centered on that guy. So I'm gonna attempt to, let me pull the back side instead because it's easier to get to because the sketch plane is in the way. I could turn the sketch plane off and not be lazy, but we're gonna grab the back side instead. And that is just a construction. Whoops, that is just a I would like that to be a construction line. There we go. Come on. Click. Alright, there we go. So now all we got to do is connect this, and I'll just tangent it. Easy enough. And we are off to the races. So these are 3mm thick. So we want to do like wall thickness plus 3mm. And then I'll come back in and, oh, I take it back. This is the area for the for the magnets. So we want to add wall thickness here. Actually, back to, I said we could do this earlier and I didn't do it. We'll do it here. It makes more sense here. There we go. And now we can come down here, and now we will have, whoops, all right, whichever, we can manually do that, the outline, and we can do the insets. So let's get this extruded, turn the body back on, wall thickness plus magnet thickness, okay, and then we'll come back over here to this sketch, turn that sketch back on. And it does want to be from this side because this side is facing the PCB over on here. So magnet thickness, okay. And that is that wiper done. So again, I will put the magnets vertically, one on each side to start out with, you know, with a 5mm gap in between them, see how that works. And then I'll slide them together in the middle and see whether or not that changes anything, whether or not this can be a little bit smaller. If we don't need the 5 gap in between, then we make this a little bit more compact. Meanwhile, let's add some some joints to this thing to make it more lifelike. As built joint between the through shaft and the magnet, 8mm magnet, rigid is correct. And then as built joint, I'll just take the whole entire thing there, because nothing in there, actually no, I shouldn't, because the through shaft is technically part of that construct, so that might make things weird. So let's take the shell and have the shell there, and we'll have the shell rigid to the PCB. Okay, and let's turn things on and let's see if this spins the way I expect it. Actually, before we do that, let's get these magnets in place. I don't need to. Let me highlight that. Turn the magnet on, turn some other stuff off for right now so that we have an easier time. And modify, align, not that point, that point. Turn the body back on, onto there. Okay, turn the body back off. Modify, align. We want actually, let's try to do this. I think this should work. Then we just spin it. Yeah, there it goes. And then we'll capture, move, copy. We want component though, not body. Create copy. And I prefer to use the this guy. And we could go -10. We know that -10 works. And now we can do a rigid group here of the through shaft to make sure all of that stuff is stuck together. And now let's hop back up in here and see how all this is working. Let me just modify plastic. That guy. Alright, cool. Now let's see if this works the way I expect it to work. Yep, there it goes. Cool. Nice, nice, nice. So again, let me turn the, I don't have the Hall effect sensors on right now, so let's turn those guys on for demonstration purposes. So you can see here, this wiper will bring the magnets over top of the Hall effect sensors, and thus triggering them. And again, these are going to be analog Hall effect sensors. So they will put out an analog voltage, which will be used to power a common cathode RGB LED, which we will now put a mount for. Actually, we have a couple options. Couple options here. We could have. So, interesting thoughts. Interesting thoughts. The fact of the matter is that we could have multiple LEDs. Just well, yeah, maybe not. So the reason not to have multiple LEDs is just that I'm not. Again, we're using the filament runout sensor as our voltage source, and I'm not sure whether or not that circuit can hold, let's say, 60 milliamps. 60 plus 6 times 3 is 1878, so 78 milliamps. So we're close to 100 milliamps. It probably can. I'm probably being paranoid here, but it probably can handle that those milliamps just fine. But it's an unknown at this point. What I was thinking is taking the PCB board, expanding it out an extra shell, and then putting 1, 2, 3, 4, maybe, 1, 2, 3, 4 LEDs on there. That would actually then be another 26. Just another 20 milliamp. Yeah, it depends on whether or not these Hall effect sensors are close enough together. So it could be anywhere between an extra. So we were at. Let me just do the math on the board really quick, so I'm not doing it all in my head. So each LED, I'm not sure if the Hall effect sensors are going to be activating multiples at a time. We could be up to 40 for 2 LEDs. 2 RG. No, I'm going to call that Indie LEDs. So the individual LEDs inside of the RGB LED. Each of those may be pulling about 20 apiece, so we might be activating 2 of those at a time, red and green, let's say, which will be 40 milliamps. And then if that is happening, that means that we also have 2 Hall effect sensors, which according to the data sheets I saw was 12 milliamps for 2 Hall effect sensors. So we're up to 40, 50, 52 here. Now if we change this to 4 LEDs rather, that will be times 4, which is 160 milliamps. This stays the same though. We're not adding more Hall effect sensors. So we are then at 172 milliamps. Again, I may be paranoid here. The filament sensor may be able to run a full 2 amps, let's say, for all I know. But it's something that is still a little bit questionable as to whether or not we add multiple RGB LEDs and whether or not that adds anything of value to the project. I kind of think it does, honestly. If we have, to visualize this, the LEDs like this, and then you have your swirly thingy right here that's spinning around, okay? Having the 4 LEDs, creating an even glow around it makes more sense. Now, obviously, this thing, you're going to want to be big enough to cover all that anyway, but the point stands is that it may be better to do 4. If we just do 1, we can't do it dead center because obviously the wiper's in the way. The center shaft is in the way, so we can't do it dead center, so we can't get it, completely on center so the glow is even all the way around. Whether or not that even matters is another point of discussion. It may be that I'm just overthinking and overcomplicating everything. So, just a bunch of stuff to think about. Let's swap back to Fusion, because we are almost done, which is why I was willing to take on this project, because I was pretty sure it was going to be simple enough. Now the trick here, what I'm going to go ahead and do is I'm going to modify this guy, because again, the point is that I want other people to be able to put their little insignia, whatever you want to call it, indicator on top here, and I would like to make that easier for them. So we will go ahead and let's hop in here to through shaft. I'm going to come back here, modify this, and give myself, let's turn the bodies off so that it makes things easier to see. Magnets, and then you guys off. And yeah, okay, cool. I'm going to unclick these guys. And I'm going to do 2 millimeters here, and I'm going to do a 2 millimeter shell around here and connect to that instead. And that will allow us to insert another magnet if we want to, if they want to, if the user wants to, onto the back here. If they don't want to, then they can just glue to this ridge here. So let's finish, and then we're going to have to correct this because obviously that is not selected. And let's see here. What happened with that? Did I accidentally... Sorry for the background noise. Oh, that is what happened. We lost some stuff. Turn the body off when I did all that. Okay. So let's do that. Okay, cool. And turn that guy on. Turn that body on. That should be a join. Why are you no longer joining? Okay. Alright, there we go. Now I can just come back here to this sketch, grab this ridge right here, and extrude it off the backside. Object, and we'll just do the 3 millimeters that our 3 millimeter magnet is. And now either the user can put a magnet in here if they want to be able to take it on and off like they normally do, or they can glue straight to this ridge. It works either way. Now the last thing to mention is that this actually was possibly a bad idea. Yeah. I wanted to have this available to center on, was the idea, was the thought. This way they have a visual point of reference to center their spinner on. The problem with doing this, let me turn the sketch off really quick, is that this has just made this very difficult to print. So before, this was printing on the flat side. Let me go here, go here. So this was printing straight up and down like this. I'll flip over to the other side so you can see it. The bed was down here. We were printing straight up and it wasn't that big of a deal. As you can see, that is kind of in the way at this point. So, things we can do. Oh, that's what we can do. Let's, instead of doing this, reverse that. That is how we can fix this problem. We can instead grab this guy. Let me turn the body off to make things easier to click. Grab this guy instead and send it the opposite direction. So minus 3 millimeters instead. And we got to turn that to a cut. There we go. Now, like I said, you can go ahead and put that in there and etc. And you have a visual point to line up on. Okay. Yep, I'm happy with that. Reasonably happy. So the reason why a ridge is slightly better than this, even though this works, is because with a ridge, you can look around, you know, you can look from the top side, the bottom side, etc. as you're lining it up to make sure that you actually are on center. Whereas with this, you're not going to see it if you put your what you call it straight up against this. If you put your spinner indicator straight up against this wall, you won't necessarily be able to tell whether or not the center of your spinner indicator is directly on center of this, whereas you would be able to at least eyeball it up with an raised ridge. So it's not as ideal, but you can always make modifications. For example, I could always do this, create new component, 6 millimeters, okay, and we can just have this extra standoff right here that the user can print to have a easier way of aligning their indicator onto this through shaft. So that was a simple fix. There we go. All that talking and it was fixed in half a second. So yeah, that should be everything we need. Oh, that's right. That is not everything we need because we haven't added the LEDs yet. Yeah. So basically, what I will do is we will come in here. I'll go ahead and use the inside of the back, and I'm going to project just this guy, just this edge, because We don't have a full circle at this point because we added this, I could backtrack. I could come back in here, roll, not edit, roll. Alright, fine, don't roll. I could come back in here when it was still a circle and start building from this point, which make more sense. And yes and no. It does and it doesn't make more sense. Basically, if I add the outer shell for the outer ring for the LEDs, it makes this circle bigger, which means that when we add this part right here, this part also gets larger. Now that is not a problem. Right now, if I add an outer shell right here, then it's, it's just a little bit of a bulb. It's not that big of a deal. It's a little bit of extra plastic around the edge, whereas if we extended this all out, then we'd have extra plastic all the way up to here and on the shell itself up here. So it seems unnecessary to me to do that, which is why I'm starting from this point. That is my rationale to start at the end here after we got everything else added, instead of incorporating it earlier on in the design. Actually, just turning stuff off, obviously, so we can see what we're doing. I'm going to make that a construction line. Well, we are no longer inside the sketch. There we go. That is now a construction line. Toss that in there, make that a construction line. Actually, don't even need to do that because we can take the, we're already, I was going to say, concentric to this, and we can just take the radius here. And honestly, it's one of those things back to 1mm holes on the for the LED to go through. So we just make that divided by 2 as our center line here, and then toss a line and another line. What I'm doing right here is the same exact thing we did for the rest of our holes earlier on when we made the holes for the Hall effect sensor. The RGBs are going to have 4 holes, so I'm just going to go ahead and actually, instead of doing this, we'll do this and this. That will make it easier, and that is collinear with that, and that is centered on that, or not centered on that. My bad. That is equal to that. And again, we will just go with our lead pitch here. And now we can have 1mm. How do I want to space these actually? It just occurred to me that it's not terribly obvious how I want to space these. Yeah, okay. Let us back up here. Which one is that line? What did I delete? Holy cow. I was trying to delete that guy. There we go. That's what I wanted. I just want to separate these off. Attempt to separate these off. Alright, we're just going to delete and start over. There we go. That's all I wanted. I just wanted to add another segment so that this was all spaced evenly. This gets center pointed on there, and this is perpendicular to that. And then we can go ahead and use these points in the center here for those, and everything is equal. And then we just want that to be quinkadink with that. And and I gotta redo my lead pitch. There we go. So those are the leads for the LEDs. So let us go ahead and, how am I gonna do this? Actually, yeah, I'm gonna go back in here and actually extrude this whole face. I only did the edge before, but we don't really want to extrude anything beyond here, so that is why I'm switching up. And let's make these guys all construction lines before we move forward. Sketch line, there we go. So again, this is the same exact process as before, and obviously this guy is a little bit closer than 3mm, or 1.5 millimeters actually, to the edge here. I'm not terribly concerned about it at this point. So let's extrude that out to there, join, and then we'll extrude the holes through just like last time. Distance all, okay. And just like last time, just like always, circular pattern, not components this time, features, those holes, and use that. And we are going for 4 LEDs. Alright, and that is everything, because now we have mounting for 4 LEDs. Again, I'm not sure that it will support 4 LEDs, but I'm also not sure that I'm not being paranoid. This actually, I did 3mm here. I'm gonna go 5 just to give myself extra space. I literally just said it doesn't necessarily matter to me. I've decided it does matter to me how close these holes are to the edge. So that concludes this design then, because we have absolutely everything we need, right? Let's just run through the checklist really quick after I have this up, and we'll hop on here. So we've got the spinner, which connects to another spinner, and we have this optional mounting thing for the other spinners in case they need it. We have sockets for the Hall effect sensors. We have sockets for resistors for current limiting. We may need to add more resistors for the Hall effect sensors. I haven't looked at their data sheet yet to see if they need it. We have sockets for the LEDs, the RGB LEDs. We may need to, let me grab an attempt to grab an RGB LED. At any rate, do I have one? I do have one in here. We may need to offset this. Sorry, digging out of my miscellaneous box, because the rest of my RGB LEDs are inside another case that I gotta dig out and are more difficult to get to. Alright, so these are this LED. So we have 2 options here. Back to the Hall effect sensors, we're bending up to save space, and so that they're facing the magnet, technically speaking. That's the more important part. But we probably want to bend the LEDs up so that they're just like we did with these Hall effect sensors. In that case, we're just looking for 5mm. Right now, I think we had, I actually can't remember. How much did we have here? We have 4. So we need at least 5 plus more, honestly, because let's face it, things never fit the way they're supposed to. And I didn't even account for the rim, so that's actually 6. So we probably want to be like 7 or 8mm. So this is going to get a little bit long, this shaft, because we gotta, let me do this. It's going to be 9 now, so you can see how far out it's sticking now. That is a little concerning that it's that far out, but it is all just plastic. This is plastic, that's plastic. You know, the components, the electronic components are effectively plastic, not actually plastic, but effectively plastic. So we're probably all right. Let me figure out where these guys are aligned at so that I can fix them. Right there, that's where you're aligned. You, and rotate. Okay. Capture position. And there we go. All right. So that's sticking out a little bit further, but at the same time, just for reference, in human measurements instead of metric, the rotator fan is now just barely over an inch out, 26mm. Go ahead, I'll prove it to you with the secondary measurement here, 1.03 inches out. So it's only about an inch out. It's probably not that big of a deal. So the last thing that's on my mind, I know I keep on saying we're done. So aside from stupid little stuff, like for example, you know, stylizing this right here. I meant to hit the play button. Which way do we want to do this? I guess I'll do it like this. You know, aside from doing silly stuff like stylizing this, the last thing to consider is the fact that this is just squeezing the motor at this point. We could, all right, looking at my Prusa, we can't really, but actually we could. So here's what we could do. The Prusa has mounting holes that go through the motor. So we could mimic those on here and basically just make a hole. This is not correctly positioned, but make a hole through the plastic for it to mount it onto the motor. We can do that. I will see what happens. It's one of those things, the getting the mounting holes, actually, because Prusa is all open source, actually I probably could find the exact mounting hole positions easy enough. So it may not be that difficult, but that is such a minor thing and it's going to require some research, which means that it's not something I feel like doing on stream right now. So yeah, that is the entirety of the design effectively. It's just a matter of putting it together and make sure all the electronics work. So for those of you who have joined me today, thank you for watching. Glad to be able to get through this in one stream as opposed to 4 like the chess pieces, and also very happy that because this is so simple, I should be able to get it done and not interfere too much with the print table contest. Again, I wanted to get that print table contest started this week, and hopefully we will be able to do that because this is simple enough. Again, it's just waiting for components and then confirming that all the electronics work as expected. So again, thank you very much for coming and hanging out. I hope you have a great and wonderful day, afternoon, or evening, wherever in the world, and I will catch you next time.